Welcome to this episode of Robert's Creative Chronicles. So today, we'll be solving these exercises on polynomials. The first exercise states that determine the value of k so that this polynomial px is divisible by this. So we'll start with this first one. Solution. And we'll start with number 1. Determine the value of k so that px, which is this polynomial, is divisible by this. Now, if a number or a polynomial is divisible by another number or polynomial, that means the one that is being divided by is a factor of that one. That means this one will be that means when this one is divided by this one, there is no remainder. The remainder will be 0. So it's trying to tell us when this one is divisible by this one, that means this one is a factor of this one. And this one is a multiple of this one. So, according to the factor theorem in polynomial, which states that when px, which is a polynomial, so when px has a factor of x minus c, it states that px will have a factor x minus c if and only if pc is equals to 0. So this is the one we're going to use. This polynomial is a factor of this polynomial. That means pc, when you substitute this one, when you equate this one to 0 and substitute it back into this polynomial, the substitution must give you 0. So if this is divisible by this, which means that this is a factor of this, if you equate this one to 0 and substitute it here, it should give us 0. It must give us 0. Not even it should, it must give us 0. So in this second example also, the same thing. They say this is a factor of this. So this one, if you substitute it here, it should give us 0. So this is the polynomial factor theory. So when this is substituted to this, if this is a factor, the substitution back into the equation must give us 0. So this means that when you equate this to 0, x plus 3 is equal to 0, x is equal to negative 3. That means p negative 3 must be equal to 0. That means if we substitute this negative 3 into this equation, we should get 0 since this is divisible by this. And which means that this is a factor of this. So therefore, let's substitute this into it. To become negative 3 cubed plus k negative 3 squared plus k negative 3 plus 3. Negative 3 cubed plus 3 is negative 24. Negative 24. This is what? 9 plus 9k. This is minus 3. Minus 3k. Minus 24. Then 9 minus 3 is what? Is 6. Plus 6k. So this becomes... So now, you know that this is 0. So we equate it to 0 here. This will be 0 is equal to negative 24 plus 6k. So we'll take this to the other side. It becomes 24 equals to 6k. So k will become, you divide both sides by 6. So if you divide 24 over 6, it's 4. So k is equal to 4. So this is the answer for the first exercise. Now let's move to the second exercise. So this is the second exercise. Show that x plus 2 is a factor of x to the power of 12 minus 4096. So in this one, we also use the factor theorem that we used in exercise 1. So see, if this is a factor of this, that means if you equate this to 0 and you substitute the value of x into this, it should give us 0. So let's show it. X plus 2 is equal to 0. Then x is equal to negative 2. That means the polynomial negative 2 should be equal to 0. So now we'll substitute this into the polynomial. So since the question says we should show that this is a factor, so that means we'll use the proving method. This is the left hand side, this is the right hand side. So we'll prove the left hand side is equal to the right hand side. So this left hand side. Let's prove the left hand side. Use the polynomial to become negative 2 raised to the power of 12 minus 4096. Negative 2 raised to the power of 12 is 4096. 4096 minus 4096. So this is 0. So p minus 2. So p minus 2 is 0. That means left hand side is equal to right hand side. So we have showed that x plus 2 is a factor of x raised to the power of 12 minus 4096 because left hand side is equal to right hand side, and it satisfies the factor theory. So this is it. Now this is the final answer for the exercise 2. Let's move to the last exercise, which is the third exercise. So here's the third exercise, and it states that for what value of m is this polynomial divisible by this? So, and you know, since this is divisible by this, that means this is a factor of this, and this is a multiple of this. So, since this is a factor of this, when this is equated, then this one is equated to 0, and is substituted in this, the remainder will be 0. So now we'll say x plus 8 is equal to 0, x is equal to negative 8. So this means that the polynomial, when negative 8 is substituted into it will give us 0, since it is divisible. So now we'll substitute this into it. It will be, so this p negative 8 is now what? It's negative 8 cube plus 3 negative 8 square minus negative 8 plus m. Negative 8 cube plus 3 negative 8 square minus 8. So it's negative 312. So this is negative 312 plus m. And you know that this is equal to 0. So now here will be 0. You know that p negative 8 is this. So now this is the same thing as 0. It's equals to negative 312 plus m. So now m will be equal to 312. M now is equals to 312. Let's take it to the other side. So this is the final answer for exercise 3. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email within the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.